All right, well, we'll get started. Today we are going to cover dplyr and tidyr, okay? And there is a great presentation that was already created by Garrett Grolmund. He and Hadley Wickham have a joint book called R for Data Science. Excellent book. We're not using it for this class, but there's a book called R for Data Science. It is available free via Safari Books Online. So I think the R Graphics Cookbook, I've linked to that. Basically, that same website, you can get R for Data Science for free there. Okay, and that's written by this guy Garrett and Hadley Wickham, who are like the heroes of R in our studio. So anyway, these the slides I just downloaded directly from this website here, and I posted it onto CCLE, and then I've created a little R code, just an R script here that you can download to follow along if you want to follow along in RStudio with your computer. Okay. Otherwise, you can just sit and watch. No problem there. Okay, so what you'll want to do is you'll want to install packages, tidyr, dplyr. You'll also, the data files, kind of the tables of data that we're using will be coming from this, this package called EDAWR. I think it's exploratory data and something with R. Exploratory data analysis with R, I think is what it is. But that's loaded on GitHub. It's not actually in the CRAN repository. So if you want to install that, you have to first install DevTools, which allows you to install packages off the GitHub. Okay, so you'll have to do that, and then you load up those respective libraries as such. Okay, and then later on in the package, we'll take a look at New York City Flights 13, NYC Flights, and so you can install that. But anyway, let's take a look. I'm going to just use Garrett's slides here. So this does not apply. That was Garrett introducing himself, and we're taking a look at tidyr and dplyr. There's also this paper that you can download, and it's the data wrangling cheat sheet. Okay. Who here has used dplyr already before? Okay. Okay. A lot of you. You're feeling pretty comfortable with it already, maybe, or not. Okay. Maybe you've used it, but you're shaking your heads. No, not comfortable. Okay. Well, I'm hoping after today you'll have a little bit more exposure, and basically you get comfortable with something the more you use it. Okay. So. Okay, dplyr, tidyr, they use what's called a tibble, all right? And a tibble is just like a data frame, except they play a tiny bit, they play nicer with the console window. So, for example, where is there a data set called diamonds? Do I have that loaded? Let me just... I think in ggplot2 there's a data set called diamonds. It's already in tibble. Okay, but if you do as a data frame and you try to look at it at a large data set, this is probably a familiar problem, right? Where it just prints out every single. It wants to print out a bunch of rows, or it says it's omitted a bunch of things and things like that. With when things are in tibble form, it is smart enough to know that, oh, your window is only this big, therefore I'm only going to print what fits in your window. Okay, and then if I were to resize it, okay, so that my console is even smaller, and I type in diamonds, then it says it only prints out the columns that fit and says there are 3 more variables, X, Y, and Z. Whereas when my console window was wide enough to fit everything, it fit everything in there. But when when I shrunk it down, it prints only what it can fit on the screen. Okay, which is a nice little thing. Sometimes you do actually want everything printed out. Okay, perhaps in your homework or something, you have an R Markdown file or something, and you want the actual entire contents printed out. You can always do as.dataframe, and it will print it out as a data frame rather than a tibble. Okay. So that's just kind of a base thing. And then view, capital V view allows you to see things in kind of the data previewer. And it loads it up here, okay? Just kind of in the graphic interface rather than in the console output window. Okay? But not to worry. That's what happens when you have something in the environment and you click it and it loads up in the this viewer out here. I think you guys are familiar with that. Okay. We're also going to see the pipe operator. Have you guys used pipes before? Basically, pipes, what they do is they take the output of one function and they feed it into the output of the next function. Okay, so sometimes you want to do something, and before pipes or without pipes, the way you would do things is you would nest, one function, and then you say, okay, I want to take that result and I want to sum them up. So then around that result, you put sum, and then if you say, okay, I want to take the square root of that, then around that sum you put the function square root. Okay, and what the pipe does is it allows you to just kind of feed things into each other. So let's say, you could say, all right, here is the vector 1 through 10. I think I can pipe vectors into the sum, okay? And then, so here I'm just piping the numbers 1 through 10 into sum, then into square root, okay? So it's very clear, it's like a linear path of what's going on. Whereas otherwise I would have to write the square root of the sum of 1 through 10, okay? Which is fine, but if things get really complicated, especially with arguments and things like that, then this nesting syntax for writing functions can get a little confusing, okay, or just harder to visualize. With pipes, you feed things in. Instead of having to type in % greater than %, there's a keyboard shortcut, and that's Command Shift M or Control Shift M on your keyboard, and that just puts down a pipe. Okay. All right. So let's talk about data wrangling. Data wrangling maybe goes by these other names: munging, janitor work, manipulation, transformation. Garrett estimates that it's between 50 to 80% of your time, maybe. Okay. Because a lot of times when you get a data set, it's rarely in a nice, clean format where you can just start doing analysis right away, right? You might be pulling data from different sources. You might be pulling, next week we'll look at just a brief look at web scraping and text processing and stuff like that, or with regular expressions, and things can be messy, and so these tools will help us deal with things like that, okay? So yeah, the goal is to make the data suitable so we could manipulate it with R, and of course we want to reveal information, all right? So here it says data sets come in many formats, but R prefers just one. Okay, and so the data tables that we're going to be looking at are loaded in EDAWR, Exploratory Data Analysis with R, I believe is what that stands for. And we're going to look at these 3 data tables, okay, storms, cases, and pollution. Okay, and so if you load up library, I think I've already loaded these in memory, but if we look at storms, it looks like this, okay? And if we look at cases, I think these are, and then if we look at pollution, looks like this, okay? So we've got all of this stuff. Storms is in tidy form. We see the column storms contains the storm name. The column wind has the wind speed. The column pressure has air pressure, and the column date has the date of the storm. Okay, so one variable in each column. If we look at the cases table and we ask what are the variables that are present in the cases table, we have the country, okay, France, Germany, and the United States. Another variable that exists in the cases table, although it's not explicitly labeled as such, is the year, okay? We have 3 years present, 2011 through 2013. The year is another variable that is present in this data table, okay? And then the other variable that we have is the count or the number of cases, okay? And that's kind of at the intersection between each country and each year. That's what we have there. All right, and lastly, if we look at the pollution table, the different variables that we have the variables city, particle size, and amount, but if we look at it, we can also think of it as city, the number of large particles, and the number of small particles. Okay, we have in these rows we have the number of large particles, and in the other rows we have the number of small particles. Those are the, we could say those are the columns that we are dealing with. Okay. The storms, the format of storms is the system that that R prefers, okay? So for example, if I wanted to extract just the storm names, I would just do storms $storm. Or if I wanted to extract just the wind speed, I would do storms $wind, etc., etc., etc. It makes it very easy to extract just that one column that you want, okay? If I wanted to extract the country name, I could do that, cases $country. But then if I wanted to extract the years, right? I have to do this, names, cases, minus the first name, okay? And then if I wanted the count, then I have to do some acrobatics here to try to get the count of all of these cases, okay? And over here, to try to get the number of large particles or the number of small particles, I have to, you know, apply indices to say these are the rows that correspond to large particles. These are the rows that correspond to small particles, okay? So these two forms are not conducive to the kinds of analysis we want to do. When you have it in tidy form, you know, each row corresponds to an observation. Each column is a variable, and you can do computations. You can say pressure, the ratio between the pressure and the wind speed. All we have to do is we just do storms $pressure divided by storms $wind, and we would get, you know, we have 1, 2, 3, 4, 5, 6 storms listed here. We would have 6 results listed here, okay? And because of the vectorized nature of these mathematical operations, R really likes data when it's in this tidy form, okay? So this is what we have. This is how we want to get our data. So what do we do if our data is not tidy? Okay, well that's where the package tidier comes in. Okay, it takes our messy data and it tries to make it tidy. Okay, and there's 2 main verbs or 2 main functions that work. We have gather and we have spread. Okay, so here it says, imagine how this data would look if it were tidy, okay? And the 3 variables that we would want would be country, year, and N, the number of cases. How would this data look if we were to make it tidy? How many columns would we have? 3 columns, right? Country, year, and N. How many rows would we have? we would have 9 rows, right? Okay, because we would have one row for France in 2011, and that the end there would be 7,000. We would have another row for France in 2012, and the end there would be 6,900. And we would have basically one row for each of these cells. So we would have a total of 9 rows. Can you guys visualize that? Okay, and so here, you know, Garrett made a bunch of slides. They said, so these are the 3 columns that we want, and we would have the first row would be France in 2011 had 7,000 cases. Germany in 2011 had 5,800 cases. The US in 2011 had 15,000 cases. France in 2012 had 6,900, so on and so forth, and we would have a total of 9 rows in this thing. So how do we go from this form to this form where we have 3 columns, 9 rows? Okay. To do this, the action we take is gather. We are going to take these columns, the values, these 9 values that are spread across 3 columns, and we are going to gather them into one column. That's why it's called gather. The data values here are spread across 3 columns. What we want to do is we want to gather them into one column. Does that make sense? Okay. So the way we do this is and to distinguish the fact that, you know, because they're all going to go into one column, we're going to distinguish them by their column heading here, and that's going to be what we call the key. All right. So we say, okay, this France 7,000 belongs to 2011. This France 6,900 belongs to 2012. Okay, and France 7,000 here is 2013. That's how we're going to do that. Okay, and then the value that we're going to do are the cells that we're gathering, and those all go into the column here. And so the way gather works is we give it the name of the table that we're dealing with, in this case cases, okay, and then we just give it 2 names, okay? One will be the name of the key, and one will be the name of the value, okay? There's no inherent meaning to these text strings, okay? If you wanted to call it Y or H or P or whatever, you could do that. And if you want to call this number or count or cases, that's fine. These are just text strings. You throw in whatever you want. They're just going to become the names of the columns, okay? Over here, 2:4, this tells gather which columns are we gathering together into one. We're saying here we're going to gather these columns 2, 3, and 4, and we're going to gather them into one column. Okay. So we've got the data frame, the name of the new key column, a character string, name of the new value column, and then finally the indices of the columns to collapse or gather together. All right, so if we do this in R, so here is cases, and if I say gather cases, and we're going to call the key column year, and we'll call the value column N, and what we're doing is we're gathering columns 2 through 4. That's what we get. Okay. But again, those text strings have no inherent meaning. I could have just used Y and N and number, and that's what happens here. Okay. If I only do, let's say I only want to gather columns 3 and 4, what it does is it will, so it's right here we gathered columns 2 through 4, 2, 3, and 4 together, okay? If I only gathered the columns 3 and 4, then I would have a total of 6 rows, and then these columns that were not gathered get duplicated for those things. Okay, and that makes sense, right? So when we gathered the columns 2, 3, and 4, the country name was duplicated: France, Germany, U.S., France, Germany, U.S., France, Germany, U.S. Okay. When I gathered just the 3rd and 4th columns here, the columns that I did not duplicate, did not gather, get duplicated for each entry there. So it kind of preserves that there. But of course, you know, it only makes sense to gather columns 2, 3, and 4. Okay, is that all right? That's the usage of gather in tidyr. Okay, and then the other question we had was we had, we had the pollution data, right? And here we want to rearrange this to have 3 variables: the city that we're looking at, the number of large particles, and the number of small particles. Okay, so if we did this, how would this data set look? How many columns would we have? We would have 3 columns: city, large, and small. Those would be the 3 columns. How many rows would we have? 3 rows, okay? And those rows would be New York, London, and Beijing. Okay? So if we do this, what we're doing here is we're taking the data that's stored in the amount column, and we are spreading these values into 2 columns, okay? Which are going to be large and small. So we've got New York goes to has 23 large and 14 small, okay? London has 22 large, 16 small, and so on and so forth, okay? And so we have 3 columns, 3 rows. And so now 1 column corresponds to each variable, and the verb we're using here is spread. The values are stored in 1 column, and what we want to do is we want to spread those values across multiple columns. In this case, we want to spread them out across 2 columns. So we use spread there. Okay. The way the key things here are, in the key we look at large and small, and these become the new column names. Okay. All of these things that had large, they get put in the large column. All of these things that had small get put in the small column. Okay. So the way spread works is we give it the data frame that we're dealing with, pollution. We're using the column named size to be for the keys of the new column. We're going to take the values that are listed in size, and those are going to be our new column names. We're going to take the values that are in the amount column, and those will go in the data cells. Okay. So here I did spread. So here's our pollution table. It has 6 rows, and if I spread the values in amount using size as our new columns, we have this. We have Beijing, large, and small. All right, and there we have that. Okay. I'm gonna in your data file or the script, I said I'm gonna make a copy of pollution. I'm gonna call this pollution 2, and what I'm gonna do is I'm going to rename pollution 2, one of the rows, to be lowercase Beijing. So if I look at pollution 2, okay, here I've got New York, New York, London, London, and then I have Beijing spelled one with a capital B and one with a lowercase b. Okay. So if I use spread here, what's going to happen is that R treats these as 2 different things. Okay. And so it successfully spread London, the values for London and New York, but then over here I've got capital B Beijing with 121, and that goes in the large, but then it says I don't have anything for capital B Beijing with small, and so it gives it a missing value. Same thing for lowercase Beijing. I've got 56 for small, but no value for large, and so it leaves a missing value there. Okay. The same thing happens in the other way. If we had, instead of large and small, if these were, there's a misspelling in one of these, or a typo of some kind. Okay, so here, if we look at pollution 3, so everything is exactly the same as the original pollution, but here I have a capital S small here, okay, for New York. I have a capital S small. And so when I spread those things out, we're going to end up getting 3 columns. I've got a column for large, a column for small, and a separate column for capital S small, because it's looking at the size column for the names to use for the new column headings. And so it said, oh, I see something for capital S small, and it creates a column there. And so New York has no value for the lowercase small, and then the other 2 cities have no values for the capital small there. Okay. Does that make sense as far as how this spread function works? So spread is very useful in terms of getting data. If your data is all stored in one column and you want to spread those out, that's what we do. Okay. And so there's a kind of a opposite relationship between spread and gather. If our data was like this and we wanted to put them all into one column, we would use gather. And if our data is in one column and we want to spread them out across other columns, we would use spread. Okay, so this is what we're doing here. Okay. There's unite and separate. These are if you want to kind of separate out different variables that are stored within one column. Okay, so for example, the dates in storms, we can separate that out into year, month, and day. We can use that. We can use separate, and it kind of looks at this to try to say we're going to use the dash as our separator. Okay, obviously that requires the data in here to be nicely formatted. And then the opposite of separate would be unite, which would be take, values in multiple columns and then kind of paste them together into one. Okay. Or you know, if you're some store and you, I don't know, the way you assign inventory numbers or something is you can do something like that. Okay, so that's what package tidier does. It just reshapes our data into forms that are tidy, that you know, is preferable for usage in R. All right, here it says data sets contain more information than they display. Okay, we're going to look at package dplyr, and this is probably my favorite package. I would, you know, and we can look at data for NYC flights. There's actually a very good dplyr vignette on, where is it? Okay, introduction to dplyr. This is what we're dealing with. Okay, I'll link this as part of your homework reading. Okay. All right, we have a few verbs here, okay, or a few functions. Select, filter, mutate, and summarize, okay? Select picks columns, filter picks rows, okay? Select chooses columns, filter picks rows, and then summarize will summarize our data. It's most powerful when paired with the function group by. Okay, so and then yeah, we have mutate to derive new variables here. Okay. All right, so here we'll start off by taking a look at the data set storms. Okay, so here we have our data in tidy form and storms here. Okay, so dplyr, you want to get your data in tidy form before starting to use dplyr. Okay, that's kind of your prerequisite. Okay, so here I have this, and if we want to just select a few columns, we would choose select, and then we list off the names of the columns. So here I would say select from storms. I want to pick the storm name and pressure. Okay. Now we could have done this using subset notation, right? I could have said pick all of the rows and the columns 1 and 3, and this would have done the same thing. But there's a simplicity in just saying select from storms, storm, and pressure. Okay. Or I mean, I could have made this similar. I could have said I want to pick storm, and I could pick pressure, right? So this is probably the most similar form here. Okay. And again, by using pipes, it's even easier. I can just say take your data set storms and select storm and pressure, right? And I don't have to put it in quotes or anything. Okay, so I don't know if you guys maybe you do, maybe you don't appreciate the difference here. Okay, so I could say storms, Control-Shift-M, select storm and pressure. And I think there's a certain elegance in having the command written this way. You just say we're looking at the data set storms, and from storms we're going to select the column storm and pressure. Okay. Whereas, sure, I could use subset notation and say and these would return the exact same thing, right? These return the exact same thing. But in my opinion, despite a few extra keystrokes, I think this is easy to understand exactly what's going on. And if you're familiar with R notation, you can understand this as well. But if you misplace a comma, or you have to remember to keep the column names and quotes and everything like that, there's a little bit more work there, right? Just like other things, you can say I want the columns other than a certain name, and you just say select from storms everything minus storm. Okay, that's fine. And an interesting thing is you can also say I want the columns wind through date. Okay, so normally you can only use colon to indicate like the numbers 1 through 5 or something like that. Here, you can say, I want the columns wind through date. And it will do that, okay? If we look at NYC flights 13, oops. What's going on here? Oh, I haven't loaded it. It's not. I don't know what happened to my data file. Yeah, it's just flights. Okay. So if we're looking at the data set flights, okay, we can see there's 19 columns, 336,000 rows, right? And we can ask for the names in the flights table. Okay, and we have all of these things: year, month, day, departure time, scheduled time, departure delay, arrival time, so on and so forth. Okay, And so what I can do is I can just say take flights, and I want to select, we'll say distance through time underscore hour, okay? And it will just pick those columns. It's smart enough to recognize that. We have, there's other nice little verbs that select understands, such as contains, ends with, matches, things like this, starts with, okay? So if I look again at the names and flights, we've got scheduled departure time, arrival time, scheduled arrival time, departure time, things like that. So I can say take flights and select those that ends with time. Okay, and it picks the columns that end with time, or something like that. Okay, I can say we can also do starts with. Okay, starts with schedule. Okay, and that will pull up scheduled departure time and scheduled arrival time, things like that. Okay, so there's these are nice little features that you can use with select to kind of just make your column selection easier. Okay, and of course you can give it a vector of values and say I want the first and the third column or something like that. Okay. So that's select. Select is for picking columns. Filter. Filter picks out rows, okay? And you can give it conditionals, such as picking where wind is greater than or equal to 50, okay? So here we're going to do filter storms where the wind gives me a value greater than 50. So here I've got storms, and I can just say storms, feed it into filter where wind is greater than or equal to 50. Okay, and there you go. Without dplyr, the way you would have to do this, you would probably have to do storms $wind greater than or equal to 50. You'd get back a vector of true and false values, and then you would subset storms using bracket notation, put that into the bracket, comma, put that conditional of trues and falses there, and do that, okay? And that's how you would do it. And I think there's just, this is easier to understand. Storms, we want to filter it just so we get the rows where wind is greater than 50 versus having to use kind of the bracket notation this way. I mean, this of course works. And if you are in a bind where, I don't know, somebody has loaded R onto your computer and but has forbidden you from installing dplyr, the package dplyr or something, then yeah, learning this will be useful. Okay, there's always a debate. In class, should we teach students to become masters with base R only, or should we teach them how to use these packages that are out there? And I'm of the opinion, let's just teach you the packages now, okay? Because I think the packages make your life easier and more efficient and quicker, and easier to go back and understand your code later. But of course, the downside of that is if somebody else wrote a bunch of code without using any packages, it might take a little bit longer to parse through exactly what they're doing. But everybody should just use these packages. They're great. Okay, you can apply multiple what do you call it? Conditions just by separating them with a comma. Okay, so we can say, I want to make sure that the storm name is one of Alberto, Alex, or Allison, and we want the wind speed greater than 50. You just say, you just apply them in there, put them in there, and it's the same thing as saying wind has to be greater than 50 and storm has to be in this. Okay, so it would be like, so In the above case, you know, I would have that logical vector, and then I have this logical vector, and then I have to do an and between these two. This is stupid. I don't know. Right? I would have to do the logical and there to get this, and then I would feed this into storms, pick these rows, put a comma, and then the bracket, okay? And then I would do that. And so it can get messier this way, right? This dollar signs everywhere, all of that. I'd rather not. Filter. Filter makes our life easier as far as picking rows, and we have all sorts of logical tests, right? These are, you know, less than, greater than, equal to, is in something or is not. We can filter things out, right? You can just say, is it missing, or I mean, is it that we want to filter out anything that's not missing? We just throw in not is NA. Okay. Mutate allows us to create new columns of variables, right? And so here we're going to say we're going to mutate storms, and the way we're doing that is we're going to create a column called ratio, which is equal to pressure divided by wind, right? So here I just say storms, we're going to feed that into mutate, and we're going to create ratio equal to pressure divided by wind. Boom, it makes that for us. Okay. Again, if I didn't want to use dplyr, there's like a few steps that I would have to do. First, I would have to create the column ratio, and then I would have to bind it to our table. Okay. This does it all in one step. The nice thing about mutate is you can also use a column that you just created and to generate another column. So here in this line of code, I'm saying mutate storms, ratio equals pressure over wind speed, which is what I just did. And in the same line, I'm saying inverse is equal to ratio to the -1, right? I can do that in the same line. If I didn't have dplyr, I would have to first create it with the ratio column, then I would have to create another column called inverse and then bind that on. You're not allowed to take one that you just created in the same stroke. So here you can do that, and it works, no problems. It's not going to complain. Okay, so those were just kind of simple things. We have other functions. These would be called window functions, and you can do things like the cumulative mean or the cumulative sum. I think we're probably, these exist in base R, but then you also have things that exist in dplyr, like the cumulative mean, right? So, for example, if I have, if I do 1 through 10, I can say, can I mutate just a vector? Maybe it will. It will allow me. We'll call this CM is equal to cumulative mean. No, I can't do that because this is not going to work. Let me just, df will be data.frame x equal to 1 through 10. All right, so I've got this very simple data frame. I can do data frame, and we'll have mutate, okay, and we'll call CS will be cumulative sum of x, and then we'll have CM will be the cumulative mean of x, okay, and it goes and it just says, okay, x, the cumulative sum is 1, 3, 6, 10, 15, so on and so forth, and then cumulative mean, as we go up, as we're adding these numbers and we're dividing by how many we've seen, it's calculating. After your fourth number, the cumulative mean is 2.5, and as we keep going, cumulative mean keeps climbing by 0.5, which makes sense if you're just adding values of one bigger. Okay, so these are the kind of the assortment of functions that you can use with mutate. And we call these window functions because you take a vector of values and it returns a vector of values of the same length. Is that okay? Mutate. All good? All right, let's take a look at summarize. Summarize takes all of your rows of information and it boils it down to one value, right? That's the whole point of a summary statistic. When you ask for the mean of a sample of data, the idea is rather than having to look at every single value, you're getting the mean of all of those, which boils down that entire sample to a single value. Or in this case, the median or the variance. We're just boiling all of these values down to a single summary value. Hadley Wickham is from New Zealand, so he spells it summarize with an S, and that's what we have. Okay, so here we're going to take the table pollution, and we're going to summarize it. And so we say we're going to create a column called median and a column called variance, and the median is equal to the median of the amount, variance is equal to the variance of the amount. What you write before the equal sign doesn't matter, okay? The spelling of that has no bearing. So if I just wanted to call it, you know, mm, it would do that, okay? There's no requirements for what has to go here. Of course, when you're summarizing your values, you want to have names that make sense, okay? So it makes sense to use median and it makes sense to use variance. But as far as the summarize function goes, what comes before the equal sign doesn't matter. What comes after the equal sign has to be a real function in R, right? I can't just say mm of amount because it's going to say I don't know what this function mm is, all right? So there is a real function in R called median, and that's why it works, because it's just taking the median of those of the amount column, okay? So I've got the pollution table. Basically, what I'm doing is, you know, if I didn't have summarize, I'd have to do pollution amount, median, pollution amount, and then variance of this, and then I'd have to calculate it that way. All right. Sometimes you don't need an actual column name in there, right? So mean, we want to take the mean of these numeric values, or we want to take the sum of these numeric values. But if we just wanted a count of how many numeric values are being summarized, we don't actually have to put in a column name there. So we just give it the function n parentheses, and it understands that this is going to just return the number of rows that are being summarized. Okay, and so we have that right here. So n will say 6 rows are being summarized here. Okay, and you don't actually have to put in a column name there into the summary function. Okay, and let me just kind of show you, if you just say mean is equal to mean parentheses, it's going to complain because it's going to say the mean of what, right? It doesn't know, like in this case, it seems obvious because there's only one numeric column, but if we looked at flights, right, and I've got all these numeric columns, I can't just say take flights and summarize the mean, okay, because it doesn't know. I could say summarize just n, and this will return, you got 336,000 rows. But, you know, let's say I wanted to know what is the, what are the names in flights again? kind of the, I don't know if it makes sense to do the median arrival time, but sure, we'll try it, okay? We'll do median, and we'll say this is going to be the median of arrival time. Well, there's some missing values, so let's do na.rm equals true. And apparently the median arrival time of all the flights is 2:35. Oh, wait, 3:30. Wait, 15 is 3:35. Never mind. Yeah, see. Okay, 15. But well, first of all, this is a bad idea to do that with arrival time for flights, because like we recognize that this represents the time on the clock 10:04, and this represents on the clock 8:12, but we would never see the time 874, right? Because our clock only goes to 59. So it doesn't make sense to do averages, right? You can't do what's the average between here and here? That's not going to work. So I'm just demonstrating that, you know, the median and the mean functions could work here, but it would be a terrible idea to try to do something like this. We would have to kind of split this into hour and minute if we're dealing with times being printed this way. Okay, but anyway, that's summarize, and we have useful functions here. Okay, you guys are all used to seeing mean and median and sum and variance, standard deviation. These are all in base R. Okay, for dplyr we have n, and, you know, first and last. These will give us the you know, kind of the number of values in those vectors and things, and these apply only if you've got dplyr loaded up. Okay, so summary functions, again, the idea is it takes the vector values and it boils it down to a single number. Okay, before we get into some cool stuff with summarize, we'll just talk about arrange. Arrange will sort your columns. I mean, not columns. Sort your rows. So in this case, if I said take storms and arrange them by wind, it's going to sort them from least to greatest here. Okay, if we wanted, and that's the visual representation of what it's doing, we could say descending on wind, okay, and you just put in, you know, arrange storms based on wind, but descending, and that's what you throw in there. You can give it multiple conditions. You can say sort based on wind and then date. Okay, so over here we have two things that are tied for 45 for wind speed, and if we want to sort that further based on date, we can do that. We can say sort by wind and then by date, and we see that those two rows get swapped with the smaller number above the next one. Okay, I think we've talked about the pipe operator already. And so rather than having to write things this way, select storms, column storm and pressure, we can just do it this way. Okay. And the great thing about pipes is you can just kind of feed them into each other. And I think this makes it easy to read. We say storms, we're going to filter where wind speed is greater than 50, and then from there we're going to select storm and pressure from those columns. And that's what we have. Whereas if you nest things in each other, the arguments and everything get kind of separated and things get a little bit lost. Okay. All right, is this okay? You can use mutate in your pipes as well. So here I'm taking storms. I'm going to apply mutate to create a new column called ratio. And then after I create that column ratio, then I'm going to select just the storm name and ratio columns. And so when I do that, that's what I get. Okay. And the shortcut to type the pipe is Control Shift or Command Shift M. Piping is great. I think you'll learn to like it. Okay. Let's take a look at using dplyr, the real power of dplyr and summarize. Okay. So over here we have the pollution table, right? And we said summarize this column amount, and when it does that, it boils all 6 values down into one value each, right? The mean of these 6 values is 42. The sum of these 6 values is 252. The number of the values that I have was 6. That's what we've got here. Okay. What if I didn't want to just boil them down to one number? What if I wanted to have it summarized on New York, summarized for London, and summarized for Beijing? Okay. This is where group by comes in. Okay. I can say we want to group by the city name, and then what is the mean amount? The mean of these 2 values is 18.5, and the sum of those 2 values is 37, and the number of values that I had was 2. We do the same thing for the 2 values in London, and we do the same thing for the 2 values in Beijing. Okay, and we get this, and we would get a value for each grouping that we have. In this case, grouping by city name. Doing stuff like this is very common. This is a common task that we have to do in R, and before dplyr, this was often a huge pain in the butt. Okay, you could use things like lapply or tapply, but if things were just a little bit off or a little bit funny, it would just blow up and not work. Okay, and so summarize and dplyr, I think, has made our lives a lot easier. Okay, do you guys have to use lapply, sapply, tapply, those things? All right, I don't know. Maybe you were a fan, maybe not. Okay, and so this is what group by does. When you take the thing first, okay. So first, here's pollution. This is, if I say pollution, show me the table pollution. This is what I see. Okay, and if I do pollution, and I say we're going to group by city, okay, it seems like it spits back the exact same thing. Like, did it really do anything? And it's a very subtle difference. Here we see, oh, there's groups. There's 3 of them. We're grouping by city, and there's 3 groups. Okay, that's the only subtle difference that has happened. Okay, the power of group by is only realized when you do the summarizing. Okay, so if I just fed pollution into summarize, it boils all 6 numbers down into one row. Now I'm grouping by city, so we're going to do pollution, group by city, and then we're going to summarize, asking for the same thing. Okay, and when I do that, now it gives me three rows, 1 for each city. Okay, we could group by, other things. So here, if I say group by the size rather than the city, now I've got two groups, large and small. Okay, and if I say give me the mean value there, then it gives you the mean for all of the large and then the mean for all of the small. So here we've got we're applying group by to the data table, and it effectively summarizes them by the groups that you set. Okay. Okay. If for some reason you want to ungroup, you can use the command ungroup, and it will get rid of any groups that you had created. All right, we can look at this data set TB, okay, for tuberculosis cases. there's a whole bunch of rows, okay? And if we just say TB, filter, let's just see, country equals Afghanistan. Did I spell this wrong? Oh, double equals, of course. It even says so right there. Okay, so it says, we have 28 rows for just Afghanistan, right? And, I could even say TB summarize and distinct country. Okay, it says I've got 100 different countries that are distinct in here. Or, we could say, how many different years do we have? 19 different years are listed there. Okay, so that's what we have. And so, if I want to summarize TB, if I just did summarize, and we want the mean number of cases, or I'm sorry, not the mean, the sum total number of cases, sum data frame with all numeric, oh, I'm sorry, not, I can't do cases because I've got, sorry, let me just see. The names in TB, oh, I've got child, adult, and elderly, right? So I can't just do cases, maybe I'll just do adult, okay? So I could do some adults, this is the number of adult cases, but it's missing because we are missing some values. So we're gonna do NaM equals true. All right, this is, that's all of the cases that we have here. If I didn't want to just summarize it just into one thing, I can do group by, okay, and we can group by country, okay, and it looks like the same, but it says now we've got 100 different country groups. And then I'm going to feed that into summarize, and we will ask for the sum of adult cases, okay, and that's what we have. Apparently, we're missing some values, so, maybe we want to do na.rm equals true. It's always a little risky when you just ignore missing values, but there we have it. Okay, so that's what we have. We could say we can call this adult is equal to that, and we'll have child equal to sum of child na.rm equals true. Okay, and then here we have our adult cases and child cases for each, summarized for each country, okay? We could group by, further, we can group by both country and sex, okay? And in this case, I've got two rows for Afghanistan, one for female, one for male, and this is the total number of cases here. I should rename this to adults. Okay, and there we have that. And then if I wanted to further, I can summarize this even further. And this just further collapses what we have into single rows here. Okay. So here in this case, the example here they use cases rather than the actual table there. But here we can see we're grouping by country and year, and so we've got this group for Afghanistan 1999 and Afghanistan 2000. Okay. And then when we summarize it into cases, it produces one row for Afghanistan 99, one row for Afghanistan 2000, one row for Brazil 99, one row for Brazil 2000, okay, where it's grouped to these things, okay. And then you could further apply summarize there, and then it will group it by country, and we'll say total Afghanistan, total Brazil, total China. Okay, because right now it's grouped them by country and year, and then you can further summarize where it will group them just by the country there. Okay. If I had written group by year, comma, country, then the first first summarize would look the same here, but then the second summarize would group all of the years together for 99 and all of the countries together there. Does that make sense? So here I said group by country, then by year. And then so if we can keep applying layers of summarize, and it groups them first by year and country, then it groups them just by the country. You know, if you switch these around, then this final table will be summarized by year, not by country. Okay, so this is what we have. So I will link to this dplyr vignette here. This is very good. Okay, and I strongly urge you to work through the examples in here. Okay. And then you'll have some things in homework 3 dealing with dplyr. And then our last bit will be on joining different kind of data frames or different data sets. Okay, and so if you've done SQL stuff, this will make sense. If you've never seen SQL, then this might be new, but it's just a lot of set theory, and not set theory, but it's just applying set logic to data tables. So here we can just take the data frame Y and the data frame Z, and we can bind those columns together, and it just does it. It says I've got 3 rows over here, I've got 3 rows over here. We're going to just glue them together, and boom, there you go. So if this is what Y looks like and that's what Z looks like, if I say bind those columns, it just does it, okay? And it says, and it renames because I've got X1 and X2 again. It just renames them there. If we say bind rows, it just glues one on top of the other. Okay, doesn't try to do any kind of reasoning or logic there. With union, it will say, okay, what do you have over here? What do you have over here? And it tries to make sure everything matches, okay? And it says, in Y you have a row where X1 is B and X2 is 2. I see that same thing, X1 is B and X2 is 2 exists already here, so I'm not going to duplicate that row, okay? Same thing with the row for C, and then for D it does that, okay? If, so I've got Y, I've got Z. Let me do names of Z. I've got this. If I renamed one of these things to be capital X1, okay? So here I've got, so Y and Z are now slightly different. And I said union Y and Z. It says it can't do it, okay? You can only do union if you've got the same column names here, okay? It's going to say in Y you've got X, capital X, you don't have capital X1, and in the other one you've got a little x1, okay? So I have to go back and change it back here, okay? So then I do union of Z, oops, sorry, union Y and Z. Okay, and it can do that, all right? So I got Y, I've got Z, it binds those two together. If I just modified one of these things so that Z, that first cell is not B but is D here, okay? So I've got Y is ABC 1, 2, 3, and Z is DCD 2, 3, 4, and I say union Y and Z, how many rows is this going to return? Okay, it returns 5 rows because it sees A, A, B, C, 1, 2, 3 exist, A1, B2, C3 exist, but in Z I've got a D2 and I have a D4. Okay, and so those are distinct rows, and so it's not going to try to like merge those two together or anything like that. Okay, intersect is just like what you would expect. Here it just says which 2 rows, or what rows are exactly the same in Y as they are in Z. Okay, and so here it just says B2 and C3 were existed exactly the same in both Y and Z. Set diff, okay, is the difference between sets. And this is actually not correct. Set diff YZ is going to be what is in Y that's not in Z. Okay, so yeah. Okay, actually, let me fix my Z. Z1 comma 1 is a B. Okay, so here we got B. Okay, so if I did union Y and Z, I've got that, and if I did intersection Y and Z, we've got that. Okay, set diff YZ is what is in Y that's not in Z, and then the other way, Z comma Y is what is in Z that's not in Y. Okay. If we wanted this table, so this is not correct. Okay, if we wanted this table, what would I do? I would have to do union set diff YZ set diff ZY. Right? And there you go. That's what you'd have. That's the Venn diagrams, right? So that would be this part and this part. The union of the non-overlap. Okay. We have joins for, so this is kind of like these things, but except we are joining tables. Okay. So rather than just saying, so with these intersect and unions, these required all of the columns to be to match. Okay. With joins, all of the columns don't match, but at least one of the columns need to match. Okay. So in this case, I've got a table called songs. All right. And the name, these would be the names of the first names of the singers of these songs, okay? And then the artists, we have, their name and what they play, okay? And so in this case, we have, we couldn't do a union or an intersection here because the columns don't have the same names, right? But we have one column that is common to both. So what we do is we say, join them, join the songs table and the artist table, and join them by using the name column, okay? What left join does is it says, give me all of the rows that are in the left table and match them up to everything in the right table. And if you don't find it in the right table, still include it, okay? And so here we got a missing value for this thing here, okay? So these match and they come over here. Okay, so here John shows up here, and so we get guitar and guitar. Paul with the bass, Buddy is missing here. Okay, George appears in the artist table, but it doesn't care. Okay, Ringo appears in the artist table, it doesn't care. Okay, because that's the left join. The right join would be just the opposite. everything in the right table would appear over here, and then it would match everything to the left. Okay. If you had multiple columns that are in common, so in the other one we just had one column, name, the name column was in common. Over here, if you have multiple names, multiple columns that are in common, so here we've got first and last, we can say do the join by using first and last. Okay, so it's going to say, okay, I've got over here I've got Paul McCartney and I've got Paul Simon, and so it's going to say we're going to match Paul McCartney to the Paul McCartney, and not these other Pauls and Johns that appear in this table here. Okay, so the left join dynamic works the same. Things that it doesn't find in the right table, it just ignores. Things that are in the left table that do not exist in the right table are filled in with missing values. Okay. Inner join requires, will only return the rows that are in common to both by the matching key, right? So here we've got the name column, and it says that's what we have. Okay. So left join will do every row in the left table. Inner join will only do the rows that are common to both. Okay. Semi-join, okay? Semi-join is the left join and the inner join. Inner join will return all of the columns between your first table and second table. So we've got song, name, and plays. So it returns all of those columns, song, name, and plays. The semi-join will return only the columns that exist in the first table. So semi-join is kind of like a filter on the first table. It's like filter this first table based on what you find in the other table, because it's only going to return back the columns that are in the first table and only the rows that exist in the second table. Does that make sense? Okay, so these are all different types of joins. You can always look up help. So once you have loaded up dplyr, you can always ask for help on join. Okay, and that will pull up your help here. And so you want to pick the help file for join in dplyr. Maybe I can expand this. I don't know. I can't zoom in. But and this will list off kind of all of the details for each of these different joins there. Okay. All right, and the anti-join is kind of like the set difference. You know, what's in the first table that's not in the second table. Okay, and that's what we have there. All right, best formats for analysis, all of that. Okay. The cheat sheets, the RStudio cheat sheet is a great resource, and so I'd say definitely download those. Especially the one for dplyr. Okay. The presentation gives a plug for DataCamp and the books that Garrett has written. They are good. They are good. I am a fan of DataCamp, but it costs money, so we won't go there. Are there any questions? No, we're good. Okay. Well, in that case, we'll end a little bit early today, and have a good weekend. I'll post up. I'll try to get homework 3 posted up soon for you guys. You guys have homework 2 due on Tuesday, and I do have office hours both on Tuesdays and Thursdays. So have a good weekend.